Parent function is critical this time. Gotta know it. Y equals x squared. This is when we call a graph narrow, when we call it wide, when we say it's been shifted up and shifted down. It is moved in that way when you compare it to this graph. So I've got some points for y equals x squared. At all these points, y is equal to x squared. And it's going to look something like this. So when we look at this graph, it has not been shifted, and it's got a normal slope type to it. Alright? If it's been shifted up or down, you can say that about the vertex. If it's shifted left or right, again, you can say that about the vertex. If the graph is wide, it's wide in comparison to this graph. If the graph is narrow, it's narrow in comparison to this graph. That's why they call it the parent function. It's where all of our comparisons come from. State whether or not the function has a maximum or a minimum value. You look at the a value of each equation. If the a value is positive, the overall idea of the graph is going to go up. So it will have a minimum because the vertex will be the very bottom point. No maximum because you can always go higher. These little arrows make you go higher. If the a value is negative, it's going to have a maximum. And the reason is, if the a value is negative, the overall end of the graph is going to be down low in the negatives, which means you will have a maximum right here at the vertex. Now, it doesn't matter if the a value is decimal or fraction. The only thing that matters is if the a value is positive or negative. So this one will have a minimum as well. Solve by graphing. Alright, this is almost exclusively done on your calculator. Some things to think about. The first thing is, what are you comfortable with doing? Second thing is, how good are you with your calculator? But all of it will be done on the calculator when you do solve by graphing. You could technically throw up a table and do it yourself, but so much faster to execute this on the calculator. So we're going to take a look at number 19. And on number 19, clear that out. I've got my y equals set up. I'm going to type in type in x squared plus, type that up, there we go, plus 8x plus 7, and you're looking to where this equals 0. So second graph, or not second graph, just graph, we see that it hits right here. Boom, boom, 2 hits. 2 hits. Did I type that in right? What's my window at? Something crazy. I'm going to switch that to your window. Negative 10, 10 is your window. Let's see if that graph looks a little better. Oh yeah, that graph looks a lot better. Alright. So, you can take and try to estimate from your graph, but that is the most dangerous thing you can do. One of the best ways to do it, there are 2 good ways, is to find out where y is equal to 0. At y equals 0, you cross the x-axis and you get those 0 values. So some of the time, if it's a whole number answer, you can find them from your table. Like we know, negative 1 is one of our zeros because you can see that y equals 0. Negative 7 is one of our zeros because y equals 0. So this is one of the solid ways we could take and find out. And again, this works really only when you have whole numbers. My dogs are acting up. Only takes effect when we have whole numbers. If you have fractional answers, you cannot answer it on your table. So let's go to number 21. I will show you the other way to do it. Of course, we're going to go in there. We're going to put in x squared minus 2x plus 1. Go to our graph. You'll notice right here, it looks like it's going to bounce. This is going to be one answer. Again, you could go into your table, and since this one's a whole number, you'll get a 0 in your y column at 1. I already know it's going to be at 1, but let me show you the other way to do it. Second calculate, we want to calculate the 0. It's just left and right bound, like we found with our maximum and minimum. Here's the point I want. I want to start to the left of it, and then I want to finish to the right of it. So left boundary, right boundary. We don't want to guess, so we're going to press enter one more time. And there's our 0 at 1, 0. So again, another handy thing to know about your calculator, it can find those points for you if you know how to ask it correctly. Looking at the last one, taking a look at this graph, got to have the calculator to see this one. You could try to factor, you could throw it in the quadratic formula, but none of those are going to be effective. And once you dump it into the calculator, you're going to understand why you could not find any zeros for that one. So we look at this graph, negative 2x squared plus 3x minus 2, number 22. We press graph, and you'll notice it does not cross the x-axis. If it doesn't cross the x-axis, you'll never have y equal to 0. And if y is never equal to 0, this graph will simply not have any solutions. So if it does not touch, there is no solution. And this is going to look something right in here. Of course, you guys would take it, pull it off of your table, go in here to your table. You'll notice there is no y equals 0 in here. Alright, due to the fact that there are no zeros. So pull some of those good values off your table. For 23 through 25, you want to find your best method. Some of my students really like to put each equation in to the calculator and pull those off as zeros using solve by graphing. Some of my students like to do the quadratic formula. I'm not sure why you would want to do the quadratic formula here, but it's effective. Some of my students are very good at factoring. This is x minus 9, x plus 4, and you could solve it this way fairly quickly. We'll get a 9 and a negative 4. It does not matter how you solve it, whether you solve it by graphing like we did up here, whether you solve it by factoring like I did right here, or whether you solve it with the quadratic function, which we'll show you later. What's most important, though, is that you have the answers correct. This is going to be, what's that going to be? 6 and 2. I'm going to have to do this one using the calculator because I cannot pop that one out of my head. So I've got negative 1, negative 7, positive 12. So you will get 1.42 and negative 8.42 as your two answers here. So sometimes, if you're pretty good at factoring, you're going to come up with problems, or come up against problems rather, that you simply cannot factor, where you're going to have a fallback. Either the quadratic formula, which works every time, or your calculator, which will work every time if you can execute it effectively. All right? And that's about it on that.